Hello, and thank you for joining us today at BOFA's Additive Manufacturing and 3D Printing Seminar. Of course, normally we'd want to meet you in person at exhibitions or in your offices, but while we can't do that, we won't let coronavirus stop us from staying in touch. Before I hand over to Luke, I'd like to make you aware of some features to help you get the most from the next hour. At the bottom right of your screen, you'll see a few functions that are useful to you and which I'm sure many of you are already familiar with. We won't be sharing copies of today's slides, so please do make notes as you go along. On the right-hand side of your screen, you'll see a notes function where you can type and save notes to your own computer. We will be sharing a recording of the seminar and the link will be emailed to you in due course. As we have so many delegates with us today, we have muted everyone's microphone and switched off video. However, we would still love to hear your questions and your comments, and you can post these using the chat function. Again, this is found at the right of your screen. If your question relates to a specific slide, please identify the slide number in your question. Anything you post will only be visible to BOFA staff, and we will answer them at the end. But if we do run out of time altogether, rest assured we will answer them soon after the event. During the webinar, we will be running polls, which is your chance to answer some questions and provide insight. Your presenter will tell you when a poll is coming up, and you can vote on screen. Simply select your answer and make sure you press submit. You can minimize any of these functions by clicking on the arrow next to them, or close them by clicking on the cross at the top right of the pop-out screen. You'll hear more from me soon, but for now I'll hand over to Luke, our Global Business Development Manager for Additive Manufacturing, who will officially open today's seminar.
Thank you, Sally. I'd like to welcome all of you to BOFA's Additive Manufacturing Seminar. It is exciting to see so many of you here this morning. Throughout my time as a Global Business Development Manager, I've concentrated on bringing much-needed filtration solutions to the AM industry, working with OEMs, distributors, researchers, regulators, and of course end users to understand the risks associated with additive processes, so that BOFA could provide the right dedicated solution for each print process, giving a peace of mind to the whole AM industry, from OEM to distributor to end user. During today's seminar, we would like to introduce you to the world of BOFA, present the science behind 3D fume risks, give you a review of the AM market, and present a great business opportunity that lays ahead. Here with us today are partners, distributors, and resellers from around the globe, both new and long-standing customers, as well as representatives from the AM industry and our colleagues from Donaldson. Welcome all. Before we start the presentations though, we would like to introduce our team. Sally, could you do the honors?
I certainly can, thank you, Luke. So I'll start by formally introducing myself. I'm Sally Newman, BOFA's Marketing and Communications Manager. I joined BOFA in 2016 to head up the marketing team, and I'm responsible for BOFA's online and offline marketing for our offices in the UK, Germany, and the US. And I also liaise with my counterparts in Donaldson. During my career, I've worked in marketing roles both in the public and private sectors. As well as introducing you to the rest of the seminar team today, I will be fielding any questions you may have, so please do use that chat function at any time. The next person I'd like to introduce to you is Josh Evans. Josh is BOFA's Applications Engineer and Head of Learning. He joined BOFA 4 years ago with a solid foundation in fluid dynamics, particle mechanics, and adsorption chemistry, which are the key components in any extraction system. Josh provides pre-sales technical advice to our sales engineers and customers to determine which BOFA system is best for their specific application. He also heads up our BOFA Academy, delivering online and face-to-face, when he can, to our customers. Today, Josh will talk to you about the need for fume extraction, looking at the legal aspects as well as health. He'll also take an in-depth look at our filters and explain what makes them the most suitable for the industry. We'll also hear from Ross Stoneham this morning. Ross is our product manager for additive manufacturing. He has a wealth of experience in the automotive industry and joined BOFA's research and development team in 2019 to oversee new product development and enhancements to existing products. Ross's role within the business has evolved, and he now works in our product management team, managing the product portfolio in BOFA's primary growth areas. In today's seminar, Ross will cover several aspects to do with additive manufacturing and 3D printing, focusing on specific processes before moving on to look at what products BOFA offers to cater to this market and what the future holds. And finally, we have Douglas Gray. Douglas joined us almost a year ago, bringing with him more than 20 years' experience in industrial sales, selling high-value equipment for technical applications. At BOFA, his focus is working with prospective and new OEMs and key accounts across our industry segments to develop long-term relationships. We'll hear from Douglas in a while when he summarises learnings from today's seminar and what you can do with that information. But for now, I'll hand back to Luke to give some background about BOFA and what makes us a world leader in portable fume extraction.
Thank you, Sally. We really have a great team here for you. BOFA International has been in business for over 34 years, becoming a leader in portable fume extraction. Back in 2018, BOFA was acquired by Donaldson Company, a global leader in filtration solutions. With over 100 years of industry experience, Donaldson continued to lead the world of filtration, taking pride in innovative technologies and solutions, backed by a talented and dedicated team of employees. We continue to align BOFA to those values and leverage the many resources to help strengthen and improve our portfolio. Through our significant global reach, BOFA is truly a global business. On the right side of the screen, you will find some facts about both businesses. With facilities throughout the world, BOFA now has a scale which is unrivaled within the industry, and clear to say we couldn't have chosen a better or more complete partner. And things do not stop there. As we continue to expand and invest in the BOFA brand, bringing new products and innovation to a wider market, we are already starting to see the benefits of joining a larger family and are proud to be a part of the Donaldson Company. Our aim for today is to present the science behind 3D printing fume risks, improve your knowledge of the BOFA product range, and present the business case for offering our fume extractors to your customers. By enhancing the earnings potential of your distribution channel through investment and support, bringing the best products to the market and meeting the needs of your customers, we offer a truly strong partnership. We are in this together, and as they say, a problem shared is a problem halved. Now, no one is quite sure who coined the phrase. Some say it comes from Japan, others claim it's a Chinese proverb, but first published in 1921 by an illustrator, Frederick Bernard, quote, "One look is worth 1,000 words," or as we know it more commonly, a picture is worth 1,000 words. In the spirit of this phrase, we prepared a short video to give you a virtual tour of BOFA. Hope you enjoy.
Welcome to BOFA International, part of the Donaldson Corporation. We have facilities in the UK, United States and Germany and employ over 250 people around the world. Paul is the centre of BOFA's operations and is the location of our global head office. Our new headquarters and centre of excellence houses all the support functions such as customer service, technical support, marketing and sales administration. With over 50 people normally based in this facility, it's usually a hive of activity. With state-of-the-art training facilities and a fully equipped showroom, we look forward to welcoming you to BOFA in the future. Also located here is our Research and Development Department, the heartbeat of BOFA. They drive our innovation, product development and support our products worldwide. Our production planners load in excess of 250 orders daily, supporting the manufacture of over 100 units with 2,000 variants and 100 product families, alongside the shipment of over 500 packages per day. Our busy goods in team receive up to 60 deliveries per day, which are all logged and put in the right location just in time to be picked for production. We use a fully integrated ERP system to remain focused on providing market-leading lead times. We can manufacture from bare sheet to finished items, which allows us to monitor both quality and the manufacturing process, from folding and shaping to sheet punching and surface finishing. This control means we're able to respond to the needs of the market through rapid prototyping of specific extraction systems. Our teams take great pride in producing some of the highest quality extraction systems in the market. Manufacturing occupies over 5,000 square metres, and in addition, we have 7,500 square metres of warehousing. We've adapted to COVID-19 restrictions, and the introduction of screens and booths are just some of the things our workforce are now familiar with. But they still take great care and pride in what they do, whether it is fitting the door gasket, applying the sealing to a unit, or wiring a control box. Our trained and experienced operators follow work instructions specific to the unit they are building to ensure standard work is followed. A central database ensures these details are kept up to date and are displayed on the operator's individual tablet, which is also used to log the progress of the assembly and start-finish times, allowing us to monitor productivity in real time. And when they have finished the assembly, it moves into test bay, where every unit goes through an extensive testing procedure. We really can say your product was working when it left us. It also helps us understand the quality issues that may occur in manufacturing, so we can eliminate them. And it doesn't end there. Each unit is cleaned, its label and details attached, and then packed, ready to be dispatched. Shipments are then made either direct to customers for local routes or loaded onto trailers destined for our logistics partner in Portsmouth. All of these actions form a continuous process to ensure our customers receive a high-level service. And so it begins again, from design to delivery. We take immense pride in the BOFA way.
Thank you, Elle. Over the last 34 years since our company was established, BOFA has delivered technology and innovation that has protected the health of millions of workers around the world. BOFA equipment also delivers real protection to production equipment, minimizes disruption, and improves process performance while delivering compliance. Today, we're a team of 250 people dedicated to our purpose to deliver the best performing equipment to our key market segments. We're part of the Donaldson Company with sales exceeding $2.5 billion and locations in over 40 countries around the world. Our products are the gold standard for the removal of harmful particulate and fumes generated during laser, electronics, and printing applications. We deliver the highest performance, exceptional service, and the best value to the industry around the world. Our resources and size mean that we have, for some time now, been investing to support the additive manufacturing world with the same expertise and commitment we bring to all of our other market activity. AM has long been used to accelerate product development through rapid design and quick delivery of samples for iteration and review. Technology and material developments now mean that increasingly AM is a viable option for the series production of components. The market is growing fast, and technology companies are responding with greater capability and material options, which bring many benefits, but also new hazard challenges. Inevitably, these developments come with the risk of occupational exposure to gas and particulate hazards for both people and the process equipment. Whilst different AM technologies bring a range of challenges, the prevalence of particle and gas hazards applies across the technology spectrum. Already, legislators are beginning to develop new standards or apply existing legislation on occupational exposure limits around the world, and so now is the time to design in or integrate BOFA solutions. Our long-standing investment in additive manufacturing means that we have the technologies and the know-how to deliver integrated or standalone solutions. This will ensure operators and equipment get the necessary protection, and that your equipment and installations are compliant and future-proof. So please enjoy this morning's event and get in touch. This is a complex area. BOFA already has the technology solutions and know-how to make this easy for you. Over to Luke.
Thank you, Doug. From its early use in the 1980s, additive manufacturing has grown significantly and now draws in over $12 billion a year in revenue, coming through both services and products. Despite this big number, the AM industry isn't slowing down. Companies continue to invest heavily in developing new technology, with more than 1,500 AM-related patents filed in the US in 2019. The US remains the world leader in adopting this technology, followed closely by European countries and strong players in Asia. The industry can be split between desktop printers and industrial printers. This is defined by the printer sale price. Desktop printers are considered under $5,000 and industrial units are over $5,000. It is estimated that over 700,000 desktop-type AM units were sold last year at an average price of $1,200, with an estimated additional 22,000 industrial-type AM units sold in the same period with an average unit price of nearly $100,000. Each of these AM printers produces process-related fume, which has its own process and/or health-related risks. We are now at the early majority adoption stage of the technology, and you will likely be encountering customers asking for safety solutions relating to these printers. Several global OEMs have already adopted our solutions, but before we talk about the solution, we would like to dive a little deeper into what the issue at hand is. But before we dive into the science, we would like to hear your opinion on the following poll. Please select an answer keeping in mind your individual answers are kept private. You should see the poll question on the right side of the screen. Please select an answer and do not forget to click the submit button. The poll will last for 30 seconds. And the question is, particles and gas are a risk to operators, equipment, and product quality during AM processes. A, I fully agree. B, I agree, but only for some AM processes. Or C, there are no hazards associated with an AM process. Thank you so much. There's a large variety of 3D print processes. I would like to introduce Ross to go through the most common process types and outline their uses, the environments in which they would be found, and the risks. And later, what product BOFA offers to help eliminate those risks. Ross, over to you. Okay, I'll let Ross fix his microphone and I'll continue. Let's talk through some of the different process types. Material extrusion is the most common form of 3D printing. The process forces material through a heating nozzle so it becomes pliable. The printer then layers the molten material until the final object is complete. Combined shear forces and heating process of polymers breaks down the material and unfortunately emits a fume, which is a health risk to the operator. I've included some graphs from a Public Health England report where the fume was analyzed for particle size, composition, and how nozzle temperature changes these variables. As one can see, particle sizes are very small, far below 1 micron, and the emission rate of particulate increases with nozzle temperature. The emissions are not just particulate-based, and as typical of heating polymers, there are also quantities of vapor phase noxious volatile organic compounds released, more detail of which can be found in that public report shown on the screen. To combat these risks, BOFA have a range of extractors which can work with most architectures of printer. We offer a complete range of connection accessories and design services, so regardless of the material extrusion printer, we will be able to help.
Thank you, Luke. I think my microphone's working now. So that polymerisation and material jetting processes typically either use a UV light or digital light to cure photopolymer resin. The resin is photoreactive, which then hardens as it's hit by the light. There are a number of opportunities for gaseous release during this process. Firstly, you have the resin itself, which may contain some compounds which cannot wait to evaporate, even at room temperature. Then, some printers heat the resin, which obviously elevates the temperature and provides more energy for other noxious gases to make their escape. And finally, you have the photoreaction itself, where even more energy is applied and can lead to further unwanted chemical byproducts. So, some of these released gases, such as acrylic acid and formaldehyde, can be hazardous to humans. Some gaseous emissions are categorized as a mild irritant, and others are fully toxic. So these chemicals can have a wide range of effects, from headaches to potentially even cancer, and the long-term health effects of exposure to these smells is under increasing scrutiny. Fortunately, our extractors do provide customers with a solution for both the printing processes, but also any post-processing, such as cleaning, which also gives off fume due to the chemicals used. The powder bed fusion and directed energy deposition processes use a high energy source to melt specific areas of material. So this can be in the form of a powder bed or solid wire in a variety of different materials, from polymers all the way to titanium. When the high energy source hits the material, a very fine emission of particles can occur. An example would be the laser from a powder bed fusion process hitting a metal powder bed. So the ablation mechanism from the laser will instantaneously boil and then condense the metal powder, creating a cloud of ultrafine particulate. So to keep these processes well controlled, typically the atmosphere inside the printer is sealed and sometimes composed of an inert gas. Or, in the case where this isn't viable, an inert source is aimed at the target area for deposition. So due to the enclosed nature of this, the process, the risk to the user's health during printing is substantially decreased. However, the user has a new problem, and that is the cleanliness inside this printer. If not kept clear of particulate, the equipment can become obstructed and the material quality compromised. Additionally, any buildup of particulate can lead to premature durability concerns, as well as the risk to the user after printing when handling any finished components. Similar risks can be present when post-processing, for example, depowdering. So again, fortunately, BOFA have been developing a new range of extractors to cater for this type of printer, both removing condensate and handling any captured fume with care, regardless of its composition. So even with a highly reactive soot, one can change the filter with safety and be confident they have optimum extraction. So now I'll hand over to my colleague Josh, and he's going to talk further about the health impacts associated with these processes. Josh.
Thanks, Ross. In this section, I'll be looking at how the emissions from these processes can affect your body and highlight the need for fume extraction. As Ross has mentioned, two key categories of contaminants on these types of processes are particulate, usually in the form of nanoparticles, and gas. We'll start by looking at the particles. On the screen, you'll see research that shows how particle size affects how far into the human body they can penetrate. I'm going to be using the term micron in this section. For those that aren't aware, 1 micron is 1,000th of a millimetre. 30 microns is roughly what you can see with the human eye. 10 microns, particles start to enter your mouth and nasal cavity. At around 5 microns, particles enter your respiratory tract. At 2.5 microns, they can enter your lungs. At around 1 micron, particles will reach the very extremities of your lungs. If you remember from the previous section, the majority of particles generated by processes like filament printing are even smaller than 1 micron and have the potential to get right into the extremities of your lungs. And as we'll see on the next slide, potentially even further. This is some research that has been conducted into the health effects of nanoparticles. I'll just read the quote from it. Insoluble or low solubility nanoparticles in biological fluid are the greatest cause for concern. Because of their tiny size, several studies have shown behaviour unique to nanoparticles. Some of them can pass through our various defence mechanisms and be transported through the body in insoluble form. Thus, some nanoparticles can end up in the bloodstream after passing through all the respiratory and gastronomical membranes. They are then distributed to various organs and accumulate at specific sites. Others travel along olfactory nerves and penetrate directly into the brain, while still others pass through our cell barriers and reach the nucleus of the cell. Several effects have already been shown in animals. Among these, toxic effects have been identified in several organs: heart, lungs, kidneys, reproductive systems, as well as genotoxicity and cytotoxicity. This shows that emissions from 3D printing processes have the potential to reach much further into the body than conventional processes. It highlights insoluble nanoparticles, which I'd expect plastics from 3D printing to be. Next, we'll talk about gases. Your lungs have roughly the same surface area as a tennis court, which gives them a huge capacity to exchange chemicals between the air and your bloodstream, especially if those chemicals are water-soluble. There are a wide variety of illnesses that can be caused by breathing in contaminated air. The more severe ones, like cancers and pulmonary disease, are of the greatest concern. But the more common ones, like headaches and skin irritations, can be very unpleasant and, if left untreated over time, can turn into more severe illnesses. On screen is data taken from the UK Office of National Statistics. If you're listening from outside of the UK, we have a population of just over 65 million, so you can scale these numbers appropriately. One of the key takeaways is that an estimated 12,000 people die every year from workplace-related lung disease. This shows how important it is to understand and control the air that you're breathing in. By reference, less than 2,000 people die in the UK every year in car incidents. Despite the death rate of occupational lung disease being 6 times higher, everyone knows you need airbags and a seatbelt. Not everyone knows you need fume extraction. Next, we'll look at the laws that are in place to protect 3D printer users. Every country has its own set of regulations, but many of them follow the same framework. The first step is to make it the responsibility of the employer to look after the health and safety of everyone on their site. You can see examples of this from across the world on your screen. This includes employees, subcontractors, or visitors who have just come in to see your new 3D printing system. It is the responsibility of the employer to look after their health. The next step is to establish occupational exposure limits. These are maximum chemical concentrations that can be exposed to in the workplace. They're known by various names. In the UK, they're workplace exposure limits. In Australia, workplace exposure standards. In the US, they're permissible exposure limits. And in Germany, they're maximum allowable concentrations. While they have different names, they serve the exact same function. On the screen is an example taken from the UK workplace exposure limits. This is representative of the majority of occupational exposure limits. The table would typically contain hundreds of chemicals, but I've just taken a few as an example on the screen. In the first column, you have the chemical name. But as each chemical has dozens of names, depending on what naming system you use or what language you speak, the second column has a CAS number, which is a registration number specific to that chemical, so you know exactly what you're talking about. The third and fourth columns give exposure limits, assuming you're working 8 hours a day, 40 hours a week. It gives a value in parts per million or milligrams per meter cubed, but this is exactly the same number, it's just a different way of measuring it. After this, we have a short-term exposure limit, which shows the concentration you can be exposed to if it's just for a 15-minute short period. This might be if you've spent all day doing your build and then afterwards you just need 15 minutes for post-processing. As the exposure is shorter, you're allowed to be exposed to a slightly higher concentration. The final column doesn't appear in all regulations, but it lets you know if the chemical is a known carcinogen, mutanogen, or similar to help you with your risk assessments. This legal framework is good, but it doesn't address one of the key concerns of 3D printing, which is the nanoparticles given off. So where could this be heading? Well, in 2019, in the USA, UL 2904 was launched, which is a standard method for testing and assessing particles and chemical emissions from 3D printing. In the same year, the HSE in the UK released their report measuring and controlling emissions from polymer filament desktop 3D printers. Both of these look at gases and nanoparticles given off 3D printers. And then in 2020, the Nano Harmony project was launched. This brings together 14 expert partners from 10 European countries and will work alongside OECD and ECHA in accelerating the development of priority test guidelines and guidance documents for nanomaterials. It's difficult to say for certain, but it seems like the majority of governing bodies are creating standard tests for nanoparticles and 3D printing processes, which would be the first step in restricting their limits. My last section is going to be looking at how BOFA filters remove these contaminants from the air. HEPA stands for high efficiency particulate in air, and these are the filters that will be removing the nanoparticles. BOFA's HEPA filters are rated to remove 99.997% of 0.3 micron particles. You'll probably be thinking that nanoparticles are smaller than 0.3 microns, so I'll go into why these are the best filters on the next slide. On the right-hand side of the screen is a diagram showing the various filter mechanisms in a HEPA filter. In this, the black circles are the particles and the green circles are the filter fibers. On the left-hand side of the screen is a graph showing the relationship between particle size on the x-axis and the filter efficiency on the y-axis for these various different mechanisms. The mechanism that most people will be aware of is sieving. This is where the particles are larger than the gaps between the filter fibers and therefore cannot pass through. However, this only works for the largest particles and filter efficiency decreases as particle size decreases. The next mechanism is impaction. This is where the particles come into the path of the filter fiber and cannot get out of the way and therefore is filtered. This works for particles slightly smaller than sieving, but again, filter efficiency decreases as particle size decreases. After this is the inception mechanism. This is where the particle tries to move out of the way of the filter fiber with the airstream, but as it cannot move as freely or because it comes into the path of another fiber, it's filtered. This works for particles slightly smaller than impaction and sieving mechanisms, but again, filter efficiency decreases as particle size decreases. The final mechanism is probably the most important for 3D processes. It's diffusion, also known as Brownian motion. For all particles, air molecules are constantly bumping into them, but because the air molecules are very small in comparison, this doesn't have much of an effect. However, when the particles get below micron size, this starts to have a significant effect and causes them to move through the air erratically. The smaller they are, the more erratically they move, and the more erratically they move, the more likely they are to come into contact with a filter fiber. This means that filter efficiency actually increases as particle size decreases. So, when BOFA says that its HEPA filters are rated to remove 99.997% of 0.3 micron particles, the filter efficiency will be higher than 99.997% for particles larger and smaller than 0.3 microns. Next, we'll look at the activated carbon filters, which will remove gases from the air. BOFA's activated carbon filters are actually made from coconut shells. These are treated to give them a huge surface area, around 800 meters squared per gram, which gives them a huge capacity to absorb different chemicals. Next, it's impregnated with particular chemicals that allows it to target contaminants. A good carbon filter will have lots of carbon, so it's got a high filter capacity and lots of contact time between the carbon and the chemicals. It will have a high surface area to give it lots of absorption capacity, and it will be packed tightly into the filter so that air cannot bypass it. On the screen, you can see a good BOFA filter on the left and a bad filter that we found built into a 3D printer on the right-hand side. You'll see that the bad filter doesn't have much carbon in it, so it doesn't have much filter capacity and almost no contact time between the filter and the contaminants. There are also dust and particulate breaking through onto the clean side of the filter, which shows that the HEPA filter was not sealed in correctly. You'll also see around the edge there are sections of the filter with no carbon. As this path will offer the least resistance, the majority of the air would have gone through these sections and would have received no filtration. Thank you for your time. I'll now pass back to Ross, who will talk about the product range.
Thanks, Josh. So BOFA has a huge range of products which provide a huge range of solutions. We understand the needs of the additive manufacturing industry. Our extractions are currently in the hands of experts and OEMs to whom they're providing valuable solutions for a growing set of problems. The current range we have utilizes the known technology from our other proven products, such as the controlled airflow, patented filtration designs, and the BOFA standard extra long filter life. We are able to offer scalable and customized solutions. So since we've already discussed the different process types, I'd like to give you a little bit more insight into the product ranges which serve them. Firstly, the 3D PrintPRO range is designed specifically for the additive manufacturing market. Our patented deep pleat duo filters give extra long filter life against the particles produced, increasing your productivity. The activated carbon technology we produce is best in class for gas filtration, for absorbing the harmful and unpleasant odors, with large beds, as Josh has described, to provide longer uptime. Finally, we are using, where possible, our IQ technology, which accurately sets and maintains gas flow rates whilst delivering an unrivaled quantity of system information, both to the user and any interfacing machine. So this consistency in flow control provides invaluable for maintaining print quality, keeping the flow regime constant, even as your filter fills and the system pressures change. So the 3D PrintPRO 2 has the lowest flow rate of the range and offers cost effectiveness, a small footprint, and a long filter life. It is best used for open framed printers, as it comes with a specially designed stapler arm to hang over the printer frame and get close to the source of emissions. Going up a step, we have the 3D PrintPRO 3. This unit is the most common choice for filament-based printing, but can also be used for vat polymerisation and other gas-releasing processes. The 3D PrintPRO 3 has speed control, which further extends the life of the filter, and you can add a return spigot for a closed-loop setup that helps keep the temperature of the print chamber steady. It comes with a number of options depending on the customer, and is applicable in the same environments as the 3D PrintPRO 2, but also some larger, more industrial targeted printers. 3D PrintPRO 4 is another step up. This unit offers the same features as the 3D PrintPRO 3, but is scaled for higher airflow speeds and filter life. This extractor is best used for the large chamber printers and high off-gassing processes. So now you are entering the world of high-end industrial machines, with complex prototype parts being created frequently, but also small-scale production printers. Again, this unit will work with most printer types and capture both types of emissions. Next is the Oracle, our best-in-class extractor. It is the choice for industrial-level additive manufacturing. The IQ operating system and smart airflow management give superior filter life and performance. As previously mentioned, the market-leading IQ control board adjusts the pump speed based on the system resistance. So this provides a stable flow regime regardless of filter saturation and other variants downstream. It can be fitted with a VOC gas sensor and integrated with the printing tool to optimize the process through use of analog control. Next up, we have the FumeCab 1000 IQ. So this cabinet is equipped with the same filtration technology as the Oracle just mentioned, but it also adds an enclosure, so one can complete some post-processing of printed components safely in the cabinet, for example, cleaning and some light depowdering. This has proven to work well for photopolymer solutions, such as SLA and DLP. So finally, our newest addition, the AM range. Unlike the 3D PrintPRO range, the AM range of products is designed for the sealed environment of AM printers and to deal with dangerous powders, as mentioned before. As these processes often run in an inert atmosphere to prevent oxidation and pyrophoric events, this range is designed specifically not to leak out expensive inert gas or leak in harmful oxygen. It comes with the high performance BOFA filtration and IQ flow control, but also ergonomically handles the riskier filter change process associated with these industrial 3D printers, providing a completely sealed, removable housing which can be taken to a remote location for safe passivation of its contents. This extractor range is suited to a much more production-based, higher value printers. So I created a table to help summarize what I've presented. Here you can easily see the process types, along with the fume types, and then finally the extraction solution that will work best. So your filament-based printers are best served by our 3D PrintPRO range. Photopolymerisation and material jetting printers can take advantage of the 3D PrintPRO 3, 4, the Oracle and the FumeCab. And the industrial level processes such as SLS, SLM, binder jetting and DED can be integrated with the new AM range, the Oracle in some circumstances, the FumeCab, or a bespoke solution that meets your specification. So you can just get in touch with one of our fine salespersons or product managers if you think that there is an opportunity we can help with. So speaking of fine salespersons, Luke, can you talk us through a way of matching our extractors to printers?
Sure, Ross, thank you. One of the ways we want to support our distributors is to provide an easy way to integrate our extractors with any printer in the market. If a printer doesn't have a dedicated extraction point, we can help by creating a custom printable nozzle or spigot. The project is always ongoing, and we are building a database of custom connections. We want to make it as easy as 1, 2, 3. Download, print, attach. BOFA's 34 years of experience brings another strength to the table. We understand that processes and machines may need a unique approach. This is why we offer bespoke solutions. If your printing tool needs a special filter, more airflow, or a totally different approach, then we can do it. A bespoke BOFA extractor to meet your needs can be designed, built, and delivered quicker than you think. If you need a bespoke solution, please get in touch with me after the webinar and we can discuss the details. As mentioned earlier in the webinar, BOFA invests heavily into R&D, especially in the AM sector. I'd like to ask Ross to please tell us a little bit about what the future may bring.
Of course. So, as is the case in most industrial markets, automation and scalable production at low labor costs is a common topic within the AM sector. Both already have analog interfacing capabilities on nearly all of our extractors, allowing the host machine to turn on and off the system, receive multiple status alerts such as filter blockage and VOC breakthrough alarms, So this is a comfort to those users who don't have the ability to attend to their extractors until absolutely needed. Further to this, both have for some time been developing our new Industry 4.0 control systems for our extractors, IQ2, which has the ability to communicate to host systems in all field bus communications protocols. We plan to carry this technology back to the rest of the range, offering digital interfacing and total control solutions to a central location. The industry continues to investigate more complex and advanced materials, so this offers new challenges in terms of filtration, and we are at the forefront, gathering evidential data and proving our solutions are effective. Working with our parent company, Donaldson, we are running material decomposition and filtration efficiency testing on the latest high temperature materials to give you peace of mind that regardless of what you're printing, you're safe. The market also continues to push the boundaries of temperature to support these new exotic materials. This brings further challenges in terms of filtration, as it challenges the mechanical makeup of our machines. We are responding to this with a new range of extractors, specially designed to handle the heat and to continue to deliver the trusted BOFA performance. We're also looking at how to expand our portfolio and serve in other areas, providing better solutions for problems outside of the printing, for example, depowdering and heat treatments. We continue to focus on safety, not only in removing airborne hazards, but also the thermal and ergonomic issues relating to the filtration and handling of metal powders. All the while, BOFA continue to improve our internal quality, be competitive on price, and challenge ourselves to improve both our products and our services to the customers. So I'll now hand you back to Luke, and you can speak through some great information translates onto the balance sheet. Luke.
Thanks, Ross. Before we get into the business case for extraction, I wanted to bring back a poll you saw at the beginning of the hour. Considering what you have learned so far, could you update us on your thoughts by selecting one of the answers on the right? Please remember to click the submit button, and as before, the poll will last for 30 seconds. So particles and gas are a risk to operators, equipment, and product quality during AM processes. I do not agree. I fully agree. I would like to understand more. And thank you, the poll is finished. So the future is bright, and we are on the path with the AM industry to bring next level solutions. Demand for filtration in the AM space is growing, and is being driven by research studies that show a clear risk from particles and gases emitted by all AM processes. As regulators are working to catch up with these findings, you will see the educational, professional, and consumer sectors get ahead of the curve, looking for safety solutions now. This is where BOFA comes in with a dedicated product range that can help you get this business. Join us and grow your portfolio with the most comprehensive AM fume extraction range in the market. Our extractors are compatible with the whole range of 3D printing tools you have in your portfolio. And based on global reports, over 500,000 printers sold per year worldwide, the business opportunity is great. With regulatory agencies pushing for safety measures and end user demand growing, we are in the adoption stage of extraction in 3D printing. In the table below, you'll see an example projection of revenue based on annual printer sales, assuming a 50% connection rate of extraction. As you can clearly see, adding extraction to your portfolio is a no-brainer. Yet another opportunity is created via aftermarket filter sales. Each extractor sold will require filter replacement. These consumables will bring even more recurring revenue each year. Finally, you can integrate our solutions as a package with your printer offering, bringing comprehensive solutions to your customers. A printer, a cabinet, material storage, and of course the BOFA extractor to filter out fume. The total package to answer the needs of your customers and increase your business potential. So we have presented our range, and most importantly, the science behind it and the business opportunity that is before us. I believe this is a good time to give our audience a chance to ask questions. Sally?
Yes, thank you very much, and thank you to all of our presenters so far. I hope it's given our audience plenty of new information and things to think about. So I am pleased to say we've had some questions through. So thank you very much to everybody who's done that. We'll do our best to go through as many as possible now. But if you don't hear yours, it means we're running out of time. But we will follow up today's event with all of the questions and answers, and also any useful links that you've seen on the screen today. And if you do think of anything that you want to ask after the event, please don't hesitate to get in touch. We'll give you some contact details at the end. When I've finished with the Q&As, please do just stay with us for a few more minutes, because we have some final important information to share with you. But for now, I'm going to ask our presenters to listen out for your name, and I'll get started with the questions. So the first question I've got is for Josh. And the question is, how do I connect extraction to a 3D printer if it doesn't have a port?
Thanks, Sally. Yeah, that's a great question. We do see 3D printers which have been created without extraction in mind, but there's a number of different solutions to this. Firstly, we're seeing lots of people build enclosures to go around their 3D printers, especially where they've got print farms, so large number of printers. Having one big cabinet or enclosure with a single extraction unit attached is a good option. As Luke has mentioned in his section, we do have printable extraction plenums that can be used to create push-pull airflows, and these can capture fume escaping from the gaps in the 3D printer enclosure. Or we do just see people cutting holes into their 3D printer, attaching an extraction spigot and removing the fume that way.
Okay, thank you, Josh. And while I've got you there, somebody's asked, where can I find my country's legislation?
Yeah, so as I said, every country's got its own set of regulations. Going to your country's governing body for occupational health is a really good place to start. We do have, if you go to the BOFA website, and there's a tab called Do I Need Extraction, and then there's another subsection called Legislation, and in there we've summarized the regulations from a few different countries. Obviously for some there might be a language barrier, but it's a good place to start.
Brilliant, thank you very much, Josh. So I'm going to move on here. I've got a couple of questions I think I'll ask to Ross. So Ross, the first one for you is, what is the range of airflows that these systems can handle?
Thanks, Sally. That's a good question. So we believe that we've met all known requirements, which means that regardless of the airflow that you need, we should have an extractor that meets your requirements. That being said, there is a couple of caveats. That being, one, we really need to understand the area over which we need to capture, because we need to set the airflow to be proportional to that, and also what needs to be captured. So if it's a gas only, then you need a little bit less airflow than if it's got nanoparticles in the environment.
Brilliant, thank you very much, Ross. Just one more for you. Is there a handheld device that can detect if a lab or room is safe, or a sort of smoke or carbon dioxide detector?
So the first thing to say is we don't actually sell this type of equipment. However, I could say that for VOCs, we use a type of handheld device called a Tiger meter, and they retail at about £3,000 British. I think I am at liberty to say others are available. Also, particulate sensors. I think there's multiple at a range of prices for different accuracy, but they're quite commonly available. And as the person that asked the question says, what you're looking for is a smoke detector, as they're referenced.
Yeah, just to add to Ross's points. So key things are VOC monitor and a particle detector capable of assessing nanoparticles, but it's really important. That will just tell you how much of that is in the air. It's really important to understand what that is, because obviously some chemicals are more harmful than others, and that's where looking at material safety data sheets, and the occupational exposure limits is really key.
Brilliant, thank you very much. Okay, I'm very conscious of the time. I know we did start a couple of minutes late, so hopefully everyone can stay with us. I'm just going to ask Luke, I've got a couple of sort of salesy questions. So Luke and Douglas, perhaps I can just bring you in. Luke, how long does a filter last in an extractor?
Thanks, Sally. So there's no one right answer for this, but I'll try to explain. Filter life depends on the material used for printing. So as an example, in extrusion processes, a PLA filament will cause your filter to last somewhere between 6 and 12 months, while a copper or fiber-filled filament will fill the HEPA filter quicker because of the contents of the filament, and give you a filter life of 3 to 6 months or even shorter, depending on how much you're printing. In general, we recommend that filters be exchanged at least once per year due to the shelf life of the activated carbon, which is at 12 months. So your mileage will vary, but we have some data that can help you decide that. You can contact us after the webinar. We can talk about it.
Brilliant, thank you. And that's where, you know, resources like Josh and Ross also come into play here, because we're able to listen to exact processes and then answer the question more accurately. So that's great. I'm just going to ask one more question. I've got loads more, but unfortunately we're going to run out of time. So this could be for Luke or Doug. How many printers can you connect to an extractor?
Will I take that one, Luke? With the range that you've seen this morning, we'd recommend 1 to 2 printers per extractor. There are situations like a print farm, for instance, where you could take advantage of a bespoke design solution. In that instance, get in touch and we'll be happy to have a look at that and help you choose the right equipment.
Great, thank you. So we've had some other questions in today about certifications, warranties, where do we sell, which countries do we sell our products into. So after today's event, I am going to pull all of these questions together, get the right answers, and then we will send them out along with the recording of the event. So please don't feel that if you haven't heard your question today, we're ignoring you. But that's all we have time for with the questions. As we approach the end of today's seminar, please just stay with us for a very short while longer, and we're going to have some final words from our team. So over to you, Douglas.
Thanks, Sally. So we hope you enjoyed today's event and found it interesting. Our intention was to draw your attention to particle and gas hazard as it relates to additive manufacturing processes. We should now be able to recognise that this is an important area that needs to be addressed. And whilst complex, BOFA is uniquely placed to equip you with solutions for now and into the future. BOFA is an award-winning business with the technology, scale and team to easily deal with these challenges, and in doing so, enable you to focus on what your business needs. We have solutions already for filament, resin and binder processes, and we'll soon launch solutions for metal powder applications. We'll support inert atmosphere needs and are actively working on high temperature extraction. So we hope you've had a good sense of our commitment and enthusiasm for additive manufacturing and recognise that we're investing to support the industry and its innovators long into the future. Please get in touch with BOFA if you need help with fume and particle hazards, and remember, good business is safe business. So that's the end of today's event. I have one final favour to ask you. Shortly you'll receive a feedback survey, and it would help us immensely to improve this and other events in the future if you could take just a few moments to complete and return it. We tried to respond to your questions, but if we did not get to your question, then please be assured we will come back to you directly. Finally, thank you for joining us for our inaugural AM seminar. We hope you found it informative, and we're very grateful for your time. Thank you for joining us again today.